So, while graphs are wonderful and a well designed graph can help us to discover patterns and trends in data and also help us to clearly communicate those ideas with others, our eyes can also play tricks on us, and that can be used maliciously by people to take advantage and use graphs to give false impressions. But it can also be just accidental, it doesn't have to be on purpose. That if you accidentally try to make your graph look too fancy, or you accidentally do certain things with it, you can make it so that it's actually very difficult to understand. So what we want to do is look at these graphs and comment on what might be misleading about them and how they could be fixed. So the first one, we've got the percent who agreed with the court, and then we have it broke down by Democrats, Republicans, and independents. And at first glance, what your eye is drawn to is the height of the bars. So we can see that the Republicans and independents are equal, but it looks like height-wise that the Democrats are times 3 in height. So it appears, if you just look at it really closely, that 3 times as many Democrats agreed with whatever this was than the other two parties. But if you start looking a little bit closer, what you notice is that they didn't start counting at 0. They started counting at 50. So really, the difference is only between 54 and 62. So it's really only an 8% difference in reality. So the heights of the bars have been skewed because the axis didn't start counting at 0. So when your vertical axis not starting at 0, it exaggerates the difference in the bars. Okay, so that could be giving a false impression as to what's really going on here. So what could they do to fix it? They should start counting at 0 and count by a consistent amount on that vertical axis, and then that would level those bars out to where the height visual difference actually matches what the 8% difference is. Okay, looking at B, we've got a pictograph where they've used these images of these garbage cans. It's labeled trash. We have some dates at the bottom and some numbers on the vertical axis. The first major problem I have with this is that there is no label on this vertical axis. Like, what does this mean? Are these tons of garbage? Is it garbage that could be recycled? Is it pounds? Is it bags? I have no idea what they are even counting. The other problem, and this happens a lot with a secondary problem that happens with pictographs, is you don't know where the actual top of this image is, right? Is the top of this image this top little dot, this fly or whatever this is? So it looks like it's, about 180 whatevers. Or is the top of this at the top of this box? Or is the top of this at the top of the can? I have no idea where the top of this image actually is. So that's a big problem. Like, where is the top of these images? I don't know how to even count this over to the vertical axis. And another big problem with using images is the idea of area. So your eyes, again, and your brain immediately is drawn to the areas of these figures, not their heights. That last figure over here, it looks like you could probably fit like 3 or 4 of these small ones inside of it. Like, it visually looks like it's about 4 times as big. However, if we kind of look at the heights, it maybe is really only, 100-ish different. It's not 4 times for sure. So the area can be, manipulates your mind. So it manipulates your brain, really, to give you that idea of like how much bigger is it, and you're drawn to that more than you are the heights. So using pictographs is really not a good idea. I know they're cute, they're pretty, but just using simple bars are much easier to understand and don't give off these false impressions. At first glance, this one actually looks pretty good. Part C does. We've got bird species in a zoo. We have the names of these birds, and we have the number of birds on the side, so we know what we're counting. We're using regular bars. They seem very easy to, follow over to the vertical axis. They started counting at 0, and this looks great, honestly, until you look at it a little bit closer. And what you realize is that they are not counting by a consistent amount on their vertical axis. So inconsistent counting. If they would relabel this so that they counted always by 6s or always by 4s or always by 2s, again, what that's going to do is it's going to re-level out those bars and make them look maybe either closer together or farther apart, depending on what the actual differences are. So this is something that usually it's not done on purpose. Usually this is just an error that you mark off your axis, either one, either the vertical or the horizontal, in uneven increments. Then your graph is going to be totally not helpful and it's going to be giving off false impressions. So to make sure you don't do that as well. And then in part D, well, I've got apples, oranges, and bananas, and they did start counting at 0, but again, I don't know what is this. They need a label here. Is it 1 apple, 2 apples, 3 apples? Is this buckets of apples? Is this, I don't know, like, for what? 4 buckets, 4 gallons, 4 bushels. So they need to have this labeled better. And then another problem that happens is with the 3D graphs. That also gives you a where is the top question. Like, do I follow this over from this back corner, or do I follow it over from this front corner? Where really is the top of these? So again, when you're creating your own graphs, which you will be doing, I recommend staying as straightforward as possible. Just do bars, don't get fancy about it, and just make them nice and easy to understand. That's better than fancy or pretty.